Hey, seventh grade. Hope you're having a great evening. Hope this afternoon finds you well. Today I want to teach you how changes to data sets affect their box and whisker plots. So please make that the title on the next free page in your math notebook. When you've done that, mark it, close it, and concentrate. So today I want to teach you how changes to data sets affect box and whisker plots. But first, let's remember how that works. So like if we look at a box and whisker plot like say this, Ms. Hopkins asked 28 students to measure their pencils to the nearest centimeter. Here is the results. Remember how we change that or think about the data set that goes with it to begin with, right? So here there's 28 students. So if we listed out all those pencil lengths that made that, there'd be 28. I don't know if I'll be able to fit them all. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8. Cool. So each of those would be a pencil length. We can't know them all from a box and whisker plot. We can know a few. We know the shortest, the lower extreme was 3. We know the longest, the upper extreme was 12. So those are two numbers we can know. If the median is 7, that would be for 28. I think that would be between the 14th and the 15th value would be the median. It would be 14 on, oops, sorry, my thing's not connecting very well. 14 on each side, so it'd be like 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it'd be like the median would be like right here. So these would probably both be 7s, though it could be a 6 and an 8. But looking at it, I would say probably both 7s. So we might know that. And then we can know that the lower quartile is around 6, so that's around the 7th or 8th. 2, 3, 4, 5, 6, 7. So probably here. So these are probably either both 6 or it can't be ones of 5. So I would say, yeah, these are both 6. So we can know a few values. Same with this one, 2, 3, 4, 5, 6, 7, 8. The upper quartile is 10, so it could be a 9 and an 11, or it could be 2 10s. We don't really know. But that's about it. We can't know all the values in the data set, but we can get some ideas. So we would know we have like 7 pencils between 3 and 6, another 7 that are 6 or 7, another 7 that are between 7 and 10, and another 7 that are between 10 and 12, a fourth of the way. So let's look at some questions that would change box and whisker plots. So you can go ahead and pause and get used to this question first. And then I'll kind of go through it if you want to take a little time on your own to analyze these graphs in your head. So this is the speed of 10 different fish and 10 different mammals in miles per hour. So sometimes we know this number 10. So like this one in particular, there'd be 10 of each. We won't always know that. Sometimes it just says it's a whole lot and we don't know how many, but here we do. So let's think about how these box and whisker plots would change if some things happened. So what if a new mammal with a speed of 35 miles per hour was added to the data set? So right now, you'll notice that's much slower than the very slowest mammal. We don't know all these values on this chart, but we do know a few, right? In the fish, we can estimate the lower extreme. Looks like it's probably about 32. The upper extreme, probably about 78. Here, the lower extreme, about 45. Upper extreme, about 65. Then we also know the median of each set, where there's 5 on each side. So the median here of the fish is about 42, I would say. But since the median's between two numbers, it's probably something like a 40 and a 44 to get 42, or a 38 and a 46 or something. So I don't know those exact two numbers. I just know that halfway between them, whatever they are, halfway between them is 42. And same here, halfway between them is about 47. So we don't know a ton about this data set, but we do know this. And what if a new mammal was added to the data set that's on the bottom that only had a speed of 35? So we'd add a new one out here to the left of 35. And the main effect that would have on the graph is the lower extreme would change from being here to being way back here. So it would change this graph quite a bit because we'd have to extend it now out to that slowest one. Everything else might change a little, like the median. If there's now 11 numbers here, the median's going to be whatever this number is instead of in between. So it would probably drop a little. So the median might change some, but we can't know exactly what would happen to that. It is possible that there's two 47s or something making this median. We don't know. So I would say if you added a lower extreme, everything else would go down a little, but the main change is the lower extreme on the graph would change by quite a bit. What if something else changed? What would happen if it was discovered that a fish previously recorded at 55 could actually swim 60? So let's think about that change. So that is if something we thought was 55 could actually swim 60, how would that change the graph? So there's 10. Like I said, we know a few. We know 42 and we know 65, and we know the median here is 47 or something, maybe 48. We don't know exactly what two numbers are making that 48, but we know that. So again, here now we have some new info. We know a number in this fourth quartile was 55. So let's see where that would be. There's 5 numbers here. So this would be the third quartile, the upper quartile. So that we would put at 50, which means, because that's that number there. So if this other one, we know this other thing here must be a 55 now. And if it could actually swim 60 instead of 55, how would that change the graph? Well, actually not at all. It wouldn't change it any. This piece here moving over here, all it means is the number that made this quartile was 60 instead of 55, but it's still higher than 50. It's still lower than 65. It actually wouldn't change the graph at all. That point of 50 is not actually on the box and whisker plot. We just see this through it. We don't see where it is, and it actually wouldn't change it at all. One other kind of change you might see frequently is this one. What would happen to the graph if it was discovered that the instrument used to record the speeds was wrong and every organism actually swims 10 miles an hour slower than recorded? So that means we take every single point in both data sets, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, and again, we didn't know very many. We did like 32 to 68. We did like 42 to 65, something like that. If everything in the whole thing moved down by 10 because our instrument was broken, 58, 55, and same, all these, every single number subtracted by 10, what would happen to the graph? There we'd almost make a whole new one, but what would happen is this would go back by 10 because it would change by 10. This would go back by 10. This would go back by 10. This would go back by 10. Everything's just going to move exactly 10 spots because everything's changing by the same amount. And really the whole graph would just move 10 to the left. And we'd have the same shape. They'd be the same spread out. Nothing else would change except everything would be 10 to the left. All right, open up your math notebook. Let's do an example of each of those together real quick. This says a movie theater kept attendance on Fridays and Saturdays. The results are shown below. We don't know how many are in the data set. Doesn't tell us here. This could be 10 different days. It could be 20. It could be 100. It could be 1,000. We have no idea. So movie theater kept attendance on Fridays and Saturdays. Here's what they found. So let's talk about some changes to this. So first, what if next Friday only 300 people came to the show? So on Friday, we don't know much. We know there's some data points. We don't know how many. But we do know some things. We do know that the lowest amount looks to be, I'm going to estimate that at like 340 or something. The highest amount probably at like 510 or something. We know the median, whatever's in the middle of all this, we know. A fourth of the way we know, and 3/4 of the way we know. So all that matters here, what if next Friday only 300 people came? So if you think about that, we'd be adding a new point to the chart and we know which one. It would be now the lowest by far new point on Friday. So that would move this extreme all the way out to 300. So if that happened, the lower extreme would become 300. It would change the graph quite a bit. You'd have to add a new point out here. Everything else might move a teeny little bit, but that would move quite a bit. That's the thing we know would change the most. What if next Saturday 425 people came to the show? So again, we don't know much in this data set about what happened on Saturday. We just know some things here. 425 is kind of right in the middle. It's like right here. So if you just added in the middle wherever it belonged, you just added one more 425 and it's already in the middle of this section, it wouldn't really change anything. There's already a bunch of values here making up that box, part of the box. And if you just put another one in there, there's just another 425 there. Not much change. It might change everything just a little, but it really wouldn't change a whole lot because it's just a spot in the middle of the thing. What if the attendance dude forgot a row and there were actually 10 more people at every show? So at that point, we got to think about something weird happening, right? It's like every single thing in our whole data set is off by 10 now. So Fridays and Saturdays, every single point on the whole graph goes up by 10. Everything's just as spread apart. This doesn't change the spread at all, but it does change where all the values would go. And that would just end up moving every single point on the graph 10 to the right on both, right? This would move by 10, this would move by 10, this would move by 10, 10, 10, and so on both. So in this case, the whole graph would shift 10 to the right. If we added 10 to every single number. So that's some common things to consider. This really helps you know box and whisker plots really well if you can answer questions like this. I hope this made some sense and helped you think about them. Some ways to think about if it did. Could you approximate what happens to a box plot if I changed an extreme? Could you approximate what would happen to a box plot if I changed a data point in the middle? And could you approximate what happens to a box plot if all the data points change? That's kind of the three possibilities we went over. I hope they make sense. If not, give this another watch. I think a second time thinking this through will help a lot. But if it does make sense, you're all set, and I'll see you tomorrow.